Alright, now in this video, what I'm going to do is go over the remaining properties of the ellipsoid particle emitter. So we've gone all the way from emission through our linear velocities, our angular velocities. So now we come down to simulate in world space. Now this is on by default, and what this means is, as soon as a particle is born, as soon as it's emitted, it now no longer cares about the emitter. The emitter is completely irrelevant to it. It gets its initial settings fired into it, and that's the end of it. From that point on, it's going to simulate relative to the world, whatever the world's doing, which generally is going to be nothing but sitting there. If we were to turn this off, the behavior of our particle system starts to get different. And let me show you an example here. If I just take my emitter and I start moving it around the scene, you'll notice that particles are spawned out behind me, but no matter where I move the emitter, the particles don't really seem to care. They're just born and they rise up into the sky because that's what they're told to do by the properties. If, however, I take simulate in world space and switch that off, these particles are no longer being simulated in the world space. They're being simulated relative to the emitter itself. So now as I move the emitter, it's like all of the particles have been parented to the emitter. As a matter of fact, if I rotate, they come right along with that too. It's almost like the emitter and the particles are now just a single object.
Right. A really cool effect that you can use or achieve with this is, say, a fireball. Let's say you have a flaming core that of rolling flames around this core that you want to travel with that fireball throughout your scene. You would want to have simulate in world space off, and that rolling flame will travel with the core of the fireball. Mm-hmm. But let's say you want a smoking trail coming off behind it. You would have a separate particle system that is with simulate in world space checked, and those smoke trail would stay in place and trail behind the fireball.
Good example. And so and he could have something like, I don't know, particles that are orbiting your fireball just to make it look cooler, and those are things that you wouldn't necessarily want to be trailing behind, so they wouldn't simulate in world space. They would simulate relative to what the emitter's doing. So it is something that, for a lot of natural effects, you're not going to need this. But if for something special, it's a good idea to turn that on. Now next we have one shot. This will take all of the particles that you're supposed to be emitting and just fire them all off at once, and that's the end of story.
Right. Really good for explosions or novas or anything where everything has to come into being at the moment that that particle comes to life. In other words, the moment that either you start the game, if your particle system has emit checked, or the moment you turn emit on via a script or through an animation.
Right, and a property that we're going to talk about a little bit later is called auto destruct, which will allow us to kind of delete out our particle system once we're done with it. And I'll go a little bit more into that and give a demonstration a bit later. But if you use auto destruct along with one shot, all of your particles will be fired into the scene once, and then the particle emitter itself will just be completely deleted from memory. Now, if you don't use auto-destruct, then take a look at what's happening here. We're firing all of our particles at once, and as soon as that last particle dies, we fire out another batch, and it'll just continue like this. So, I mean, if you wanted like almost the cartoony puffs of smoke to be coming out of something, you could do it like this.
Smoke signals.
Or even better than that, if you had an old train, chugging along like the Hogwarts train in Harry Potter, which you can actually see a little, coming out of the top. You could have a constant trail of smoke coming out the top, and then a second particle system that was just there to emit these globs, and you could just keep firing those off, like have 3 of them stacked up at a time. They just fired them off in succession, right. And you could handle it like that.
Another quick one, first-person shooter, dark corridor with sparks that you want to have emit at regulars. You could tie it in with an animation.
Yep.
Have a different number of sparks emitted. The uses of it can go on and on. It's just a matter of how creative you want to be with these techniques.
Exactly. So, all kinds of different things you could think of. So let's go ahead and turn that back off, and these just go back to emitting constantly. Now, next we have the size of the emitter. Now, this is maybe closed up on your end, so when you expand it, this is just size in X, Y, and Z. So we've got 1 by 1 by 1. I could just as easily make this something like, 10 by 10 by 10, and I have a much larger emission surface. However, with emitting as few particles as I am, things look a little bit sparse, so I'm going to crank up my number of particles being emitted to something probably well beyond anything reasonable. And now you can really start to see that overall size of the ellipsoid taking shape just because of the number of particles. Now, again, not making any commentary on efficiency and whether or not you should or shouldn't ever add this many particles, I'll just crank that up to 500 just so you can see this next property, which is emitter range. Actually, before I jump down to that, I just want to say, again, you can update each one of these properties at different sizes. They don't all have to match each other. I just want to make sure I'm clear on that. So like, for instance, if I take Y and I set that to 0 and give our particles a second to die off, you'll see what I'm actually creating is a disk of particles, and then they're kind of rising up. As a matter of fact, if I was to take my velocity, which I believe I'm using local here, and we set this to 0 and give a little bit of second for the extra die off, we have a nice thin disk of particles being born here. I just wanted to point that out. You can change the shape of that ellipsoid in any one of your axes as suits your purposes. So let's set that back over to 10. And I'll put just a little bit of local velocity back in. Like I said, it's nice to see a little bit of motion in there. Now, at the very bottom, we have min emitter range. This is the minimum range of emission that will be allowed in your ellipse. Basically, what this means is how much of the internal area of your ellipsoid do you want to use for emission. If you have this set to 0, you're using the entire density, the entire area of your ellipsoid. And you can actually see that. All inside here, we've got particles being born in every single nook and cranny. If I was to set this to 1, it's a 0 to 1 property, by the way, and give everything a second to die off, take a close look at what we have. As a matter of fact, if I take the camera inside, it becomes a little easier to see.
Now it's kind of like a shell.
Yep. We have pushed the point of emission to the outermost extents of the ellipsoid. Now, I can take this to, say, 0.5, and we only have a kind of a core, like a inner area, which is not allowed to have any particles being emitted within it. So you start to kind of increase the thickness of that shell, and you can pull it all the way down to like 0.2, and now we just have this much smaller area. You can steadily bring that down smaller and smaller, and really what that does is allows you to control the size of a small shell inside in which no particles will be emitted. So those are all of the remaining properties that we had left for an ellipsoid particle emitter. Now, in the next video, we're going to go over the mesh particle emitter. And a lot of the properties that we've already covered, things like emit, min size, min energy, min and max emission, world and local velocity, all of that stuff is still going to come along just like it did with the ellipsoid particle emitter. So I'm not going to be going over all of those properties. Once again, they do the exact same things they did before.
Right. It just has some additional properties, and that is what we'll be covering.
That's right. So I'll see you in the next video where we will talk about the mesh particle emitter.